Greetings, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to look at the first lesson into Unit 3, and the title of today's lesson is Angles Formed by Transversals. Please copy down the title as well as our objectives. Our stated objective for the day is to learn the basic categorical names for sets of angles occurring around transversals. Now, transversal is a definition that we're going to come across here in just a moment, but we have already seen several types of angle pairs through our discussions in Unit 1, and today we're going to come up with 4 additional sets of angle pairs. The language objective, which you do not have to copy down, is a student will apply the new definitions in order to identify angle pairs in provided diagrams. Your essential question for the day is, can I identify the new angle pairs? As always, anytime you need more time to copy something down, please press pause and then hit play when you're ready to move on. All right, let's take a look. Now, first thing we need is a definition for this new word that is showing up here, transversals. A transversal is simply a fancy name for a line that intersects 2 or more lines. Any line that intersects 2 or more lines. Okay, so here's a very basic diagram. You see we have 2 black lines labeled A and B, and then a red line, C. And as you can see, the line that is labeled with the C does intersect 2 or more lines. Okay, so by this definition, line C would be considered to be a transversal. Nothing really fancy to it, no real properties involved with it. It is simply any line that intersects 2 or more lines. Now, as we will run into in geometry, and as will be the case in geometry, as you'll see, the diagrams simply get more and more complicated. It does not mean the definitions get more complicated, it's just the diagrams get more complicated, and that usually means more cluttered. So it is possible to have multiple transversals in a diagram at once. In fact, it is very frequently the case when we run into a diagram that has transversals going on in it, it tends to look more like the one at the bottom than it does the one at the top. And in the case of the diagram at the bottom, every single line that you see there, the black, the red, the blue, and the green, all of those lines are transversals because they all intersect 2 or more lines. Okay. Now, when a transversal intersects 2 lines, there are angles that are formed around the intersections. Let's take a look at what that might look like. Okay, here is a diagram that we're going to use repetitively throughout the course of this lesson. And once again, we have a red line in the diagram, color-coded, that is a transversal. And our transversal does in fact intersect 2 or more lines. And what we're going to see is that there are 8 angles that are formed around the intersection of this transversal and the 2 black lines. Okay, there's one at the upper left corner, another one at the upper right corner, lower left, lower right, and then of course you have the other intersection with the transversal, upper left, upper right, lower left, and lower right. So very clear to see there are 8 angles that are formed by the intersections of these 3 lines. The focus of today's discussion is going to be the categorical names that are associated with these angles that are based upon their locations around the transversal. Okay, so let's take a look at what these categorical names might be. The first one we're going to look at today is called corresponding angles. Now, the basic description for corresponding angles is that they are angles that exist in the same basic location but at different intersections. Of the four types of angles that we're looking at today, this is the one that causes people the most trouble because it doesn't actually sound like it means what it actually means. They are angles that exist in the same basic location but at different intersections. All right, throughout the duration of this lesson, we're going to use this same diagram over and over again. So there's no reason to copy it down over and over. Please just add the specific information as we come across these new definitions. Okay, so considering this diagram that we already have, corresponding angles are angles that exist in the same basic location but at different intersections. And like all of these definitions are going to be, this is in regards to the position of the transversal. So from one intersection to another intersection along the transversal. So for example, angle 1 and angle 5 are considered to be corresponding angles. And the reason that angle 1 and angle 5 are corresponding angles is because they are both in the same basic position, which would be up and to the left from their intersections with the transversals. Now obviously angle 1 and angle 5 are not the only set of corresponding angles that exist in this picture. We could also state the same case for angle 2 and angle 6, which are both up and to the right of the intersections around the transversal. We could also say the same thing about angle 3 and angle 7, which are down and to the left from their respective intersections. And we could also say the same thing for angle 4 and angle 8, which are down and to the right from their respective intersections around the transversal. And all four of those sets of angles would be considered to be corresponding angles. Now, we're not saying anything about their measurements just yet. The term corresponding angles simply refers to their positioning around the intersections. Okay, so let's take a look at the next set. Okay, the next type of angle that we're going to talk about are the alternate interior angles. Now for the remaining three sets of angles that we're going to talk about, the angle pairs, their names basically describe how it is that you find them in the picture. Alternate interior angles, it tells you exactly how to find them. Alternate interior angles are angles that are on alternating sides of the transversal. Now, alternating sides of the transversal means that one of the angle pair are going to be on one side of the transversal, the other of the angle pair will be on the other side of the transversal. And then the term interior means they are both on the interior of the two intersected lines. Now, interior means inside space. Okay, so we're looking for two angles that are going to be one on one side of the transversal, the other on the other side of the transversal, but the two lines that the transversal intersects, our two angles, are going to be on the space that is in between them. So let's take a look at this same diagram again. Okay, so there is the same diagram. You do not need to copy it down again. So let's see if we can find this definition. We're looking for angles that are on opposite sides of the red transversal, but we are looking for the interior space between the two lines that the transversal intersects. So one possibility for alternate interior angles would be angle 3 and angle 6 in this diagram. They are on opposite sides of the transversal from each other, and they are definitely in between the two black lines that the red transversal intersects. They are not the only set of alternate interior angles in this picture. We could also make the same case for angle 4 and angle 5. They are on opposite sides of the transversal, and they are in between the two black lines. Now, this does not say anything about the measurements of angle 4 and angle 5 or angle 3 and angle 6. It simply tells us where to find them within the diagram. All right, let's look at the third set of angle pairs that we're going to talk about today. Okay, the third set of angle pairs that we're talking about are called same side interior angles. Now, once again, these basically describe exactly how you find them in the diagram. Same side interior angles are angles that are on the same side of the transversal. So this time we are not on opposite sides. We're going to stay on the same side for both of the angles in question. But we still are on the interior, as the name would suggest. So still on the interior of the two intersected lines. Okay, so once again, using the same diagram once more. Same side interior angles will both be on the same side of the red transversal, but still in the interior space between the two black lines. So you can probably guess already one example of same side interior angles will be angle 3 and angle 5. They are on, in this case, both the left side of the red transversal, and they are in the interior space in between the two black lines that our red transversal intersects. They are not the only instance of same side interior angles in this diagram. There are also angle 4 and angle 6 in the diagram, and they are also same side interior angles. Now, one other little tidbit that we need to pay attention to and take note of is that same side interior angles have a synonym that go along with them. Same side interior angles are sometimes called consecutive interior angles. I would say that these two terms are pretty much entirely interchangeable. You are just as likely to see the term same side interior angles as you are consecutive interior angles, so we obviously need to know them both, because if the test or any other thing calls these angles by either name, we need to know exactly what they both mean. Okay, let's look at the final set of angles that we're going to talk about for today, and they are called alternate exterior angles. Now, once more, alternate exterior angles describe exactly where to find them in the diagram. They are angles that are, once again, on alternating sides of the transversal. The only thing that's different about these guys is they are on the exterior of the two intersected lines. So this time we are going to stay out of the interior space around that transversal. So using the same diagram one last time, we are looking for an angle pair that are on opposite sides of the red transversal, but this time not caught in between the two black lines. So angle 1 and angle 8 would be an example of alternate exterior angles. They are on opposite sides of the red transversal, and they are definitely not on the interior space between the two black intersected lines. And they are not the only instance of alternate exterior angles. We could also say that angle 2 and angle 7 are examples of alternate exterior angles. Okay, there's one last situation that we need to become very aware of. This is an important little catch to all four of these angle pairs that we have just discussed. With all of these types of angles, there is only one catch, and that catch would be these names. Okay, corresponding angles, alternate interior angles, same side interior angles, alternate exterior angles. These names only apply around one transversal at a time. Now, we've already discussed the situation where multiple transversals can exist in a diagram at the same time. Okay, these names only apply as you travel along a single transversal. Let me show you what I mean by that. Let's say we are looking at a diagram like this one. It's very similar to the one that we looked at earlier when we said that there can be more than one transversal. In this particular diagram, there are 16 angles that are formed. I would like you to focus on the 3 that are marked right here. Okay, following along with the angles that are marked right here, we would absolutely be able to say that angle 1 and angle 2 are in fact corresponding angles. They are corresponding because they have a transversal that connects their locations, and they are both in the same basic position at different intersections. They are both down and to the right of that transversal that is running vertically between those two intersections. Along the same lines of reasoning, we would be able to say that angle 2 and angle 3 are corresponding angles because there is a transversal that connects their locations, connects their intersections, and they are both down and to the right of their respected intersections. So they are corresponding angles. However, the transitive property does not apply here. We cannot say, since angle 1 and angle 2 are corresponding and angle 2 and angle 3 are corresponding, that means angle 1 and angle 3 correspond. That is incorrect. We cannot say that angle 1 and angle 3 are corresponding angles, and the reason is because there is not a transversal that goes from the intersection at angle 1 over to the intersection at angle 3. Okay, so this would be true of any of the names of angle pairs that we've talked about in this lesson, not just corresponding. That just happens to be the example that I picked on. But since there is no transversal connecting the intersection by angle 1 and the intersection by angle 3, then none of the terms that we have talked about will actually apply to those two intersections. All right. Last thing you need to do is write a summary, okay, wrapping up the information about the 4 different angle pairs that we just talked about. Jot down any questions that you may need to come in and have addressed at tutorial time or whatever. And always keep in the back of your mind your essential question: can I identify the new angle pairs? If you can, then you're probably good to go. If you cannot, then we're going to need a little practice. Again, I appreciate you finding time to get your notes taken care of, and I will see you in class.